There you go. Well, hello, and hello to everyone who's just now starting to join. My name is Whitney, or Whit, and I'm a GMAT, GRE, and Executive Assessment instructor here at Manhattan Prep. So welcome. Happy Sunday night. Happy end of February. We have one more day. Crazy. Cannot believe. Tonight, we are going to look at a concept of ratios, but I think we're going to look at this in a way that maybe most people don't always think about them or see them. And in fact, ratios are extremely common on the test and are actually really applicable in problems where they don't even use words like ratios. We're actually going to see, for the most part, that most problems we do tonight are not going to say the word ratio at all. And we'll see that ratios can overlap with a bunch of different content areas, including geometry, and a bunch of strategy areas, including things like picking our own numbers and plugging in. So let's get started. I'm going to just give us a problem to begin. Now, in general, the average DQ, so discrete quant question on the GRE, we'll spend about 2 minutes on. So we won't be doing any QC questions tonight, just DQ problems. But we'll start with a couple of, maybe like easier questions. We'll see. We'll warm up. Yeah, let's warm up. So here is your first question. We'll take about 2 minutes to solve. I'll get a timer started on my end. When you have an answer to this question, just type it in the chat window to me privately. Enjoy. I'm starting to get a couple of answers in. If you have not sent me your answer yet, send it to me privately in the chat window. Just give me the answer letter, A through E. And I'll take just another 10 or 15 seconds. So we'll be wrapping up, or at least make a guess. All right, if you have not yet, go ahead and put in a guess. Put in whatever guess you like, but just drop it in the chat window. I'm still waiting for responses from about 3 people. I'm gonna give you all a chance to answer. Nice. I like the guesses that are coming in, okay. So we have a few things going on with this problem. And so the first thing I want to highlight for the evening, and we're just going to keep seeing this come up over and over and over again, is that the way we recognize a ratio is that we are sitting in a relationship that is by nature multiplicative or fractional. And so this will be things like 3/5 as many, half as many, twice as much, twice as many, 50% more, 25% less, increased by a factor of a quarter, reduced by a half. So all of this is this idea of multiplying or dividing a number, a comparison of two values that are, again, multiplicative. The alternative would be if it said there are 5 more apples as bananas, or than bananas in that case. Now we're talking about still relative amounts, but we've moved into concrete numbers. There are 5 more. There are 6 fewer. As long as we're in the world of multiplicative, we are in a world where ratios apply. So first kind of rule is multiplicative equals ratios. And we can certainly start to set up things with variables and equations, but as seen from folks submitting answers and how long it took for even some of the earliest answers to come in, often when we set up equations, it's really messy. And if we're setting up equations, we'd have 3 variables, a variable for apples, bananas, and cherries, and then we'd have to think of total as well. So too many for me to find it worth it. The test is quite fast, right? We don't have all the time in the world. And so let's think about how we can set up these multiplicative relationships without having to go down the route of long equations. Yeah. So we'll start with the first relationship. There are 3/5 as many apples as bananas. That's such a bizarre number. That said, if I look at it, that fraction is the relationship between apples to bananas. It is the ratio of apples to bananas. In fact, if I had wanted to turn this into an equation, I would write it as a fractional ratio of 3:5. And then I've written it and could manipulate it if I needed a fraction, right? And needed it to be an equation. But I'm not going to go that route. I'm going to stick with my ratios. I then have another ratio that compares bananas to cherries in a ratio of 1 to 2. What I'd like to do is start to combine ratios. So let's get a little kind of set of instructions. So step 1, each relationship, so between 2 things, gets its own ratio. So I'm not going to initially put apples, bananas, and cherries all together unless they told me the ratio of apples to bananas to cherries was 1 to 3 to 5 or something. But each relationship, as given individually, is going to get its own ratio. Once I have multiple ratios down, if there are such things, right? So if multiple relationships, I'm going to combine these ratios using the common term, whatever term or terms are common. And so I might have 3 ratios or 4 or 5. Right now I just have the 2. And the thing that brings them, that's like their common piece, so now we're combining, in this case would be the bananas. They both contain bananas. And so I'm going to combine them by finding essentially what we would consider a common denominator. So we're going to treat ratios just like fractions, but we don't have to care which is the top or the bottom anymore. We're just going to find where they match. So in this scenario, bananas and bananas match. So what I need to do is I need to convert one of my ratios, or maybe even both, but so that the number for bananas is the same, so that I can then snap my 2 ratios together. If I multiply my second ratio through by 5, I can convert that 1 into a 5. But in order to keep the ratio fixed, I have to multiply everything through by the same amount. And so we've got 5 and 10, and we still have our ratio of 3 to 5 over here on the left. Now I can bring these 2 together, and I see the ratio of A to B to C is 3 to 5 to 10. From here, step 3 would be to create any additional, let's call these columns in our ratio based on what I need to solve for. So in this case, the fraction of the total number of apples and bananas and cherries, I need that total. Now I am allowed to add or subtract any of the values in my ratio to each other. Right, so I can add like A plus B or A plus C, or I could make a column for C minus B. So I'm allowed to add or subtract the values to each other. And I'm allowed to multiply. So I'm allowed to create a new item by multiplying or dividing a single item times an actual value. So I could, if they had said, well, what's twice the number of A? I could, it might not be the most helpful, but I could make another item for 2 times A or 4 times C or something along those lines. So for this problem, they're asking us for the total. Total will always be the sum of my parts here. So a 3 plus a 5 plus a 10 is 18. Now, if no real values are given, which is kind of the world I'm sitting in right now. So if no real values, treat the ratio amounts as if they were real values. Essentially, this is a game of picking our own numbers. If there are real values given, so if a real value is given, we're going to try some of these today. Real value is given, then convert or manipulate or sort of ramp up and down, convert the ratio to match the real number. All right, so this is us. This is where we are. We're doing it. We are going to now take this one, no real values given. Everything is kind of this relative amount. And so I'm going to treat the 3, the 5, the 10, the 18 as if they were the real numbers that were given to me. So what fraction of the total number of apples, bananas, and cherries are apples? Well, apples would be 3 out of every 18, or 1 to 6. 1 to 6. And so our correct answer is A. Okay. And I guess I should have mentioned that we are allowed to kind of like pull the individual ratios back apart. We can divide one by another. Right? What we don't want to do is multiply any of our items times one another, because weird stuff starts to happen. So we want to be really careful with that. All right, let's keep all of this the same. I'm actually going to clear it off though, so that you can practice if anybody, maybe didn't have, it wasn't the easiest thing to try and bring some of those ratios together. Let's do it again. Same upfront information, but now we've been given a new piece of information. Yeah. So practice, kind of clear off. Don't look at your notes from before. Practice trying to set these ratios up again and combine them so that way, if you struggled on the last one, you get a little more practice. And then we'll see what to do with this new kind of like weird additional bit of information. Enjoy. Try and get an answer in around the 2:15 to 2:30 mark, right? At least I guess. All right. If you have not given me an answer yet, give me, right? Pull in with something, guess. So we've got the same setup as before, at least initially. We've got the ratio of apples to bananas is 3 to 5. The ratio of bananas to cherries is 1 to 2. We're going to bring those together based on the bananas by multiplying that banana cherry ratio up by 5. Our new ratio is apples to bananas to cherries. So 3 to 5 to 10. And now I'm going to create any additional columns in our ratio based on what I need to solve for. This says there are 54 pieces of fruit in the basket. That would be total. So I need a total column again. We'll do that same thing. This time the total is 18. And it says how many apples are in the basket. So technically the only thing I actually care about anymore are apples in total. I don't even need bananas and cherries. And so I can do a couple of things. One, I can go ahead and separate out apples in total. I'll show you how that might save us when numbers are a little ugly. But right now I've got apples to total is 3 to 18. And we saw before that this is the same as 1 to 6. Now, if I stayed with the ratio the way it was given, the 54 pieces of fruit are the real value that I now need to convert my ratio to match. And so this 18 isn't supposed to be an 18. It's supposed to be a 54. What I need to figure out is the multiplier. Now I can use my answer choices a little bit here and say, well, okay, in this weird set where I know I only have 18 pieces of fruit, the number of apples is 3. So that's wrong, and kind of scale up. Or I can figure out what the multiplier is here. You can grab your calculator, or you can look and say, well, 3 times 20 would be 60. And so this multiplier is going to be 3. I can double check it, but this multiplier will be 3. So I need to multiply this same apples by 3, which gives me 9 apples. If I worked from the reduced ratio of just apples to total, since in this case we are able to reduce it, now moving to 54, we might be able to see this math a little easier that I'm multiplying both by 9. Either way, it doesn't matter if you kind of extract the ratio or if you keep it in the big one. But if there were 54 pieces of fruit total, it was because there were 9 apples. There would have been, in this case, 15 bananas, multiply that by 3, and then 30 cherries. Yeah. So this is what we have to do. That'll be a little different if we're dealing with actual values. We might put our ratio together and then have to manipulate the ratio, either scale it up or scale it down in order to match the real numbers we've been given. Yeah. So let's do it, right? If these were kind of our, all right, here's how we do it. Let's give it a try. Let's try some harder ones. Yeah. Let's scale this up a little bit. Yeah. Let's give this one a go. And again, get me your answer in and around 2 minutes. Once we start applying ratios, it actually can make these questions quite fast once we set them. Awesome. And as you're getting answers in, type them in the chat window. So that way they pop up, but just privately. But looking good. I've got everything down to one of two answers. And the answer that everybody's either picking is the right one or the best trap answer of all of them. Like a beautiful trap answer. So let's look at how we might set this problem up. And so one of the things that will happen is that when people see this, 4-to-3 ratio, candidate A has, 4 versus candidate B. So candidate A is to candidate B a 4-to-3 ratio. Often what will happen is that people will see this and go, okay, then it's that 4/3 or like 3/4 of them went to one versus the other. And they'll start doing some kind of like kooky math on just the 3 and the 4 up against this 8,400. Or maybe divide the 8,400 by 4. We got a lot of folks that ended up on that B. But what I want to think about is I set my relationship, A to B. And I didn't have multiple relationships, just the one. But then I need to create any additional columns. And here's how we keep ourselves out of trouble. 8,400 votes is the total. So what I have to do is from my A to B, I need a total column, which would be 4 plus 3 is 7. It's the 7 column that now I need to convert up to 8,400. Now, all of my answer choices have some zeros on them, so I can sort of toss all these and this and say, what do I do to convert 7 up to 84? Well, 7 times 12 gets me 84. And so now I multiply that by my candidate A. And so I have 4,800 votes for candidate A. It can be also useful to note that if there are 8,400 votes and there was a tie, it would have been 4,200 votes for each person, for candidate A and for candidate B. This was 50-50 split. However, more people voted for candidate A. So this number has to be bigger than 420 or 4,200, and that number has to be smaller. So my value for A has to be a number bigger than 4,200, and that would help keep me out of the most common trap answers, which in this case is B. B is the most common of the trap answers. Okay, tricky, right? Tricky. Okay. So let's do it again. Let's see, how can we move this world of ratios? Again, even when they don't say ratio to us, how can we start to think about ratios? Once you start to notice how much they have in common. This question is actually quite a tricky question. It's actually a very hard question. So I'll give us a timer. And again, send me your notes in and around the 2-minute mark. Okay. Not getting a ton of answers on this one. Things are a lot trickier, huh? So talk to me, type to me in the chat window. What was it about this problem that was particularly tricky? What about this one made it a bit more of a challenge? So share that in the chat window. I would love to get a sense, because this is definitely a tricky problem. Let's get a sense. What was it? Oh, messy numbers. Felt like we had to kind of like almost work backwards. That's all going to be true if you're using expressions and variables. Yeah. Right. Like that's absolutely going to be true if we try to do this with expressions or variables, which is why we're going to avoid that for this problem. And again, let's set them up. This is multiplicative. I've increased by 25%. I've decreased by a third. So we'll take where we've got this piece. And if there are multiple relationships, we will keep each relationship as its own ratio. That's what normally gets people with this problem, is that they try to do one number and move it across. Exactly. So a lot of times if people don't start with this, like picking out, not the answer choices, but putting them in a ratio, they end up taking 2, 3, 4 times as long solving the problems. The GRE is not a math test. It is not trying to see how good of a job you are at formal algebra. It's trying to see how quickly you can solve problems using quantitative concepts, but like real world logic. So let's do it, right? Let's set up our ratio. If I go from Jan to July, I go up by 25%. So let me think of a number that would be easy to do that with. I'll go 100 up to 125. Now, traditionally, what I will do is and I didn't add it here, I will reduce ratios. So let me add a little note that if they're kind of big and ugly, I might reduce them, right, as needed. So a ratio of 100 to 125, if I divided both of those numbers by 25, for example, this would be a ratio of 4 to 5. All right, now I'm going to look at my relationship between July and December, and I'm not using 125. I'm not using 5. I'm using a whole new ratio, because remember, if I put two ratios together, like build two ratios, I can always put them together later. That part's easy. So what would be a number that could decrease by 1/3? Well, I'm just going to use 3. This will go from 3 down to 2. I do not have to pick fancy numbers. What I need, though, is to bring these ratios together using the like common terms, so step 2. So let's make July equal to 15, which means I multiply both of these through by 5. So December is 10. And then to get to January, I multiply both of these through by 3. So January is 12. And then I put the real number in. If the price of the stock in December, it's right here, was 100, oh, that's about the easiest multiplier I could come up with. I'm going to convert that to 100, which means I convert everything else up by 10 as well. What was the stock worth in January? We don't end up with messy numbers at all if we stick with the idea of a ratio. Yeah? What do you think? Do you feel like trying ratios now? Have I almost sold you on not using the real numbers? Okay, good. Good. Okay, I want to try a slight, we'll stick with another one of these. Let's grab you another one, kind of practice the same thing again. I am allowed to have different ratios, right? 2 totally separate ratios. They do not have to be the same. It makes my life a lot easier to deal with, in fact, if I don't have to keep using the same ratio, right? Like makes my life kind of a lot easier. So let's try, here we go. Let's try this one. This time some answers are coming in a little bit faster. Okay, I dig it. I like it, I like it. Take another couple of moments if you haven't finished solving it yet. Nice. All right. So for this one, I have something that increases by 25%, decreases by 20%. I might go the route of picking 100 and see what that looks like. I might also just pick really lazy, easy numbers. If I'm not sure that the percentages will always be pretty, something that I can increase by 25%, right? I certainly could go from 100 up to 125 from Monday to Tuesday. I would then want to reduce that most likely to 4 to 5. And then from Tuesday to Wednesday, I went from 100 down to 20, or excuse me, down to 80. I went down 20%. Kill off some zeros, that's 10 to 8, or I can cut both in half. That's 5 to 4. Wait, hold on. Monday to Tuesday to Wednesday. So what you're saying is I went from $4 an ounce up to $5 an ounce and then back down to $4 an ounce. That would mean that what was the price from Monday to Wednesday? How did the price change? It didn't, right? It did not change because we can't add and subtract percentages just like 25 minus 20. If we have multiplicative relationships, we have to look at how they move on us in this way, right? That I have to go up by 25%, but now I'm coming down 20%, which seems like it's a smaller amount, smaller percentage, but I'm taking 20% of now this new bigger number. So I went from 4 up to 5. I have to reduce from 5 back down now. But again, I think it makes things a lot easier if we can just use real numbers, throw them in place, see how they work. So even things that seem like they'd be really simple to just do with algebra, I'll still argue that you can get them done faster and more accurately if you do them with a ratio. Again, anytime I can look at things in this multiplicative way. Let's try another. Yeah. Let's do this one. I'll just kind of keep moving through some in practice. I'll convince y'all that ratios are the way to go. All right, I started to get a bunch in right away. Are these feeling a little bit easier, y'all? What do you think? Yay. Yeah, so we're starting to find this relationship. Okay, company J has 3 times as many employees as K, so I can write that. Even if we end up going down some route of equations, it's good to look at these relationships. So J relative to K, J has 3 for every 1 employee that K has. K has half as many employees as L, so K has 1 for every 2 that L has, which that makes things really easy. I can just smash them together already. And so I've got J to K to L is 3 to 1 to 2. Then the employees of company L, that's this one, represent what fraction of employees at the company combined? 3, 4, 5, 6. So my total is 6. 2 out of 6 is a third. And there we go, we're done. I'll take it, Emily. I'll take the genius moniker. I didn't do this, math did this, but it is really nice to see how this applies, right? Like, these can be extremely confusing problems where we start picking variables and plugging in all these numbers, right? I can just set up a ratio, make my life a whole lot easier. All right, one more. And I love this next one that we're going to do. We'll then throw in like kind of a weird style of question. But I love this question because when people try to do this with percentages, never fails. They always screw it up. Right, so I want you to read it first, and I'm going to show you what most people do. And then I'm going to have you do it with percentage, with the actual ratios. So people see this and they'll say to themselves, okay, April is 15% more than May. So if April is 460, then if I just take 15% back off of it, I'll get back down to May. But we saw in that up and down that you can't do the math like that. But you'd better believe that if you grabbed your calculator, wherever the heck my little calculator is. So if you grabbed your little calculator, I found it. So if you grabbed your little calculator and you put it up onto the screen, right? And took 15% of 460, brought that down, or did the sort of fancier way of saying, 0.85 times 460, you'd actually get the number 391, which is wrong. Because if I take 391 and increase it by 15%, I won't get up to 460. It won't get me there. So I want you to try and see if you can figure out how to set this up using ratios. Set it up using ratios. And then that way, right, make your life a million times easier. All right, I'll get your timer going. Enjoy. I'm getting a lot of answers in already. Nice, y'all. That's quick. That's really fast. Keep working. You haven't given me an answer yet. All right, so what is the relationship we're given? We're given a relationship between April and May. And April, it doesn't matter the order you write them, but April had 15% more sales than May did. So let's say May's 100, that's easy to increase by 15%, right? We go from 100 up to 115. And then I'll say, okay, they sold 460 toys. I could reduce this, but that's kind of ugly. Before I go reducing it, I usually reduce when I'm going to combine ratios. I don't necessarily reduce when I'm just going to mess with one of them. So if Brand A sold 460 toys in April, so this is actually not supposed to be 115. It's supposed to be 460, which is 115 times 4. And so I'm going to multiply this by 4, which means I multiply that by 4, which means how many did it have in May? It had 400, and that's answer choice B. I didn't have to do any equations. I didn't have to do any longhand division. I didn't have to do anything fancy. Yes, good, right? Yeah, I mean, I could totally do the divide by 1.15, but I will say this, you're still doing algebra. And I don't like to do complicated algebra. I like to work with just simple numbers. You have a calculator. It's true, but it's on screen, y'all. And if you're going to be taking the test at home on a laptop, you're not allowed to have wireless peripherals. Everything you use, like a mouse, has to be plugged in. And so now you're having to click on answers, but you're also having to use your calculator with a trackpad or even with a mouse. So I want to minimize the amount of time, like the number of times I need to use my calculator. Right? And so for something like this, I wouldn't even need to break out the calculator because I know the number is going to be clean because that's just how the test usually works. And so I want to be able to keep my numbers nice, clean, and pretty. And if I can get into the habit of doing it all the time, then I don't have to think about like, oh, this is a time where I would do the algebra because it's like maybe a little bit easier. This is the time where I would move to ratios. I just do it the same way every time. No, using a calculator doesn't hurt your score, not at all. What I find happens though, is that people accidentally miss keystrokes, right? Because you're clicking on it with a mouse or with a trackpad. And so I watch people make calculator errors all the time. That's why. So for some problems, sure, right? We'll need calculators and we'll use them. I'm not saying don't, you should totally use your calculator if it's a value that could use it. But if I know that using ratios can keep me out of decimals and can keep me in whole, clean, easy integers, I might as well, like make my life a little bit easier. So we've seen all of these so far where we either have like a single ratio or we have a couple of ratios, we bring them together. Maybe we make a new column for something like a total. And then we like maybe incorporate a real number that we've been given. I want to show one other thing that usually kind of intimidates people, but I want to make sure you know that it's allowed because it is allowed. And so we'll go back to our apple, banana, cherry relationship, right? And we'll put our, I'll get it back down again. Apple, banana, cherry, this 3/5 to 1/2. We get to a ratio of 3 to 5 to 10. I want y'all to see if you can figure out how to answer the question. Like what I would need, what kind of column I would need to come up with, or right? Can I stay in ratios even? Do I have to move it? What do I have to do? All right, so who, and fess up, put it in the chat window, who's sitting out there like not really sure how to come up with what to do with this 21? What do I do with it? Yeah, right. What the heck do I do with this 21? So I said something before, but I kind of just like said it and then off we went, was the idea that we are allowed to add or subtract any of our values to each other. Like I can add apples to bananas. We've been adding apples to bananas to cherries to get a total. We've done that already. What we haven't done is subtracted, but we can, we're allowed to. So in my current universe, the universe where I have 3 apples, 5 bananas, and 10 cherries, in this universe, there are 7 more cherries than apples, right? Like if this were the actual number of apple, banana, cherry, there would be 7 more cherries than apples, because this is really just the relationship of C minus A, which in this universe is 7. But what I've been told is that that number is not supposed to be 7. That number is actually supposed to be 21. Turns out it's the exact same thing. It's nothing has changed. We do it just like anything else we've been doing. So I look for my multiplier, I multiply it by 3, and then I figure out how many bananas. Okay, I'm gonna multiply that by 3. There are 15 bananas. Just to prove it to ourselves, if I multiply everything by 3, that becomes 30. Multiply that by 3. This is 9. Yep, in fact, 30 minus 9 is 21. And I can get to the exact same place again. So long as I'm adding and subtracting, I can do whatever I want. And I can multiply any item by like a value. So I could have a column for 3/4 of a C. I could have a column for 2B plus 2C. I could have a column for 3A minus 2B. Any adding and subtracting of my columns, and then any inclusion of like integer values, like multiplied times them. No, so it has to be a multiplied number, add or subtracted variables, okay? I am not allowed to add or subtract a number. Add or subtract each other, multiply by some integer. So I want you to see how we can take what would be an annoying kind of problem, because I want you to see this in geometry. An annoying sort of geometry problem that doesn't even necessarily seem, at least to me, this problem does not ever seem like it would be, like it wouldn't be something I initially would have ever thought of as ratios. But turns out it's a fantastic ratios problem. And so let's try this one. And then we've got one other weird scenario that's also really fun that we'll try after this. I'm sorry, I didn't start y'all's a timer on this one. So let's take maybe one more minute. Hopefully you're not all sitting out there trying to do a bunch of algebra, defining a bunch of variables. Because I won't lie, that's not like the most fun. Not the most fun. All right, let's start by setting up our ratio. And then I'll pull back and give you all a chance to play with it a little bit. So I've got a ratio of width to height. It's a ratio of 16 to 9. What is perimeter in terms of width and height? Anybody want to share, like, how do I calculate the perimeter? So if I draw my little, right, like this is width and this is height. Yeah, exactly. But here's what I said. I said we're allowed to add any of these pieces together. So let's imagine my TV was actually a 16-inch by 19-inch TV, or 16, whatever, right? If I added width plus height to each other, they'd be 25. But to get my perimeter, I need to add 2 widths and 2 heights. So I need to double that. So I can do that. I'm allowed to do that. So I'll double my width plus height. Look at me go, which is 50. But what did they actually tell me my perimeter was? It's the exact same thing all over again, right? I just set it equal to the number. I go like, oh, okay, cool. This is 100. That's what in the real story, like in the real world, it's supposed to be 100. And now I multiply everything that I need times 2. How many inches wide is the monitor? It's 32 inches wide. Ta-da! I'm really hoping you guys like this one. I really like this one. So if what we're doing is adding or subtracting I like to think of these as sort of like columns. As long as we're adding and subtracting these columns to one another, I can stay inside my ratio. Where I start running into trouble is if they wanted me to find the area where I'm now multiplying width times height, then we're not really allowed to do that. So I'm allowed to add any of my columns together. I can subtract columns from one another. I can double, triple, quarter, right? Like my columns. So as long as I'm using a number, I can multiply and divide. As long as I'm using other columns, I can add and subtract. So I start with the ratio they gave me, and I start creating columns for the information they want me to solve. My rule is, and I'll kind of put this here again, so jot this down, I cannot add or subtract. The way it's written, I can't add or subtract a number from any column. So I couldn't say, okay, let me make a column for W minus 5. Because W minus 5 isn't keeping the relationship moving all together. So I can't add or subtract from any column. And I can't multiply any variable, right? Like, or any one column from the other, right? Like of the values times each other. So I can't multiply width times height, for example. I can divide, but that's because a ratio already is sort of a fraction. So I can take W over H, but that's the 16 by 9 it already kind of is. Okay. I want to show you how this can also make what I think are some of the most annoying problems a little bit easier. Let's go with yeah, let's go with this one. All right, it's a little bit trickier, I think. And so it's this like, I'd use up some, like I have a ratio and then I'm like subdividing a piece of my ratio. So what I want to offer is I want you to be able to see this. We're like, oh, okay, hold on. This is this like weird remainder, or I've got like a couple of groups and then I'm further subdividing one of them. To set this up in a standard ratio can be tricky because what ends up happening is I'm taking a ratio and then I'm further subdividing one part of the ratio, but I can still do it. Or we can use like kind of using a ratio to help us pick a good number to manipulate. So what I'd start with is that on Monday, she mowed 2/3 of her lawn. So mowed to total is 2 to 3. Now, when we start saying remaining, that means that there's actually the one part of this ratio that we're not thinking about. So if I want to include it, mowed to unmowed to total is 2 to 1 to 3. And this is the piece that I need to mow 1/5 of. So I'd really like this to be something that I can mow 1/5 of. And so I'm gonna roll this whole thing up by 5. So if her lawn was 15 meters on the first square meters, on the first day, she mowed 10 square meters. On the next day, she mowed 1/5 of the meters. So we'll go another mowed to unmowed. So she mowed 1 square meter and left 4 of them unmowed. And so I should still add all the way up, 10 to 1, 4. Yep, that's 15. So what fraction was left unmowed? It would be 4 out of 15. I find that while these look very much like the ratio problems, I wanted to highlight that these are a place where if there are no real values given, if there are real values given, we kind of want to hang out in this ratio because we want to be able to convert back up. It's not as common, but what would happen there is I would say, okay, now this M, like this mode has to get lumped in here. So my new ratio, my converted ratio would be like mowed to unmowed to total. And so I would have 11 meters mowed, meter squared. I'd have 4 unmowed and 15. I have to reshuffle, and now I would scale it up to a real number. And scale it up to my real number. Alternatively, I would go ahead and pick a number based on, like, even if there were a real number, I could maybe make this work. I have something that I need to have like a 2/3 of the lawn, 1/5 of the lawn, or a part of the lawn. I could start with a smart number, pick my own number. So I'd say, all right, if the lawn total was 15, then on day 1, she mowed 10 and the remainder is 5. On day 2, she mowed 1 and the remainder is 4. Now I would put it into that ratio if it was easier at this point, if I had to scale it up to match a real number. So I'll argue that these where it's like we get to a remainder, usually I'll try and like pick some sort of number, or I think about, I use the ratio to help me figure out what the best numbers are to try out for the problem. So again, these get much more complicated, but I think in the end, to think of it this way, or to think of it like a ratio, can still be a nice way to organize your thoughts. Okay, one more. And this one's pretty advanced. Like this one, we actually often teach to like, there's like we'll sometimes offer like an advanced like course, and this one will teach to that. But hopefully you'll see that like turning it into a ratio makes it completely doable. Doesn't feel that much different than everything else we've done. Oh, and I just realized, hold on, there's a typo. Just kidding. This is supposed to say, oops, I'll fix it. There we go. There we go. Let me restart your timer. I had one of my groups as a typo. Try that again. All right. Now I will give you this. We do want to think a little bit of some, maybe like intuition, that if the difference between grad and undergrad students is over 5,000 people, but it's not like graduate students are everybody, we want to be careful of numbers that are way too small. But I'll be honest, in the middle of the test, I don't know that I would be doing a lot of estimating with numbers this sort of like all over the place. So what's the ratio we know? Well, we know the ratio of graduate students to everybody. Okay, so let's start there. I know that the ratio of grad students to total students is 65 out of 100. Which means that undergrad students are the other 35%. So if there were 100 students at my school, 65 of them would be grad students, 35 of them would be undergraduate students. The difference between grad and undergrad, that's the other number they give me. So the difference between grad and undergrad, again, if I'm in this scenario where there are 100 students, 65 are grad, 35 are undergrad, my current difference in this like invented universe is 30. And what they tell me though is that this number is actually meant to be 5,100, which is a bunch, right? 5,100. So this might be the place where I grab my calculator. So I bring my little calculator over and go, okay, 5,100 divided by 30. Let's just see what I get. Yeah, it should be 170. So let's double check that. 170 times 30 is 5,100. Okay, so I'm going to multiply this thing up by 170, which means I need to, how many students enrolled? I multiply this up by 170. So now I got to track my 17000. And there it is. This question's like super hard. Now, what I could do though, is I could work backwards from my answer choices. And I would pick kind of like nice, clean, round numbers and just like benchmark a little bit. Like imagine, what if I had 10,000 students? What if I had 15,000 students? You could calculate the 65% that would be grad students, the 35% that would be undergrad, and then subtract the difference. But trying to do this thing with algebra is not going to be fun. Not even a little bit fun. So lots and lots of problems where you can apply the idea of a ratio. Notice that in every single situation, performing the ratio was the same. I figured out what my relationship was between like any two things. And then I started to expand my ratio based on what I needed to solve for, either by adding up stuff or subtracting it. If they didn't give me any real numbers, I just treated the ratio as if they were the real numbers. If they did give me real numbers, then I scaled up whatever the appropriate column was to match that real number, and then I solved. But it is the exact same every single time. I know to apply, or at least to strongly consider applying ratios anytime I see these multiplicative, 75% of, 4 times larger than, by a factor of 25%, 2/3 of this, 1/2 of this, double that. Right? Every time I'm in these multiplicative relationships, I'm looking for the opportunity to set up these ratios because it keeps me out of heavy calculator. Notice this problem was the first time, I'll be honest, that I used a calculator the whole time. On the whatever this was, 10, 12 questions we did, I used the calculator once just now. So I want you to think about the fact that this is going to make, this makes your life so much easier. It really can, so much easier. So a good number of these questions came from our 5-pound book. We also have a bunch of questions that I also pulled from our actual quant strategies guide. So we've got lots of questions that you can get from us, right? Also, a couple of other next steps. If you haven't done so, you should be taking a practice exam just to like evaluate where you're starting, what areas need work, what areas already feel good. You can take a free practice exam with us on our website. There are tons and tons of free study resources. And in fact, you can take the session 1 of any one of our 9-week courses for free. All you have to do is just sign up for the session 1, come try it out. Our session 1s are actual session 1s, full of people who paid to be there for the whole course. So we spend the whole session 1 actually doing content. We spend only a tiny, tiny little blip of time talking about, you know, like the syllabus or, you know, your resources and how to find them. But I teach that class. We all teach session 1 as if everyone sitting in the room is with us in class for the whole 9 weeks. We don't use a whole bunch of time in session 1 to just like, let's redo the syllabus and let's talk about, no, we're doing real things. We have a lot to cover in 9 sessions. And so if you come to session 1, you're going to learn all of the tricks for, say, quantitative comparisons. You'll learn the key process for text completion, sentence equivalence, and you'll get pretty far into your first lesson on reading comprehension. You'll learn all about the full structure of the GRE, and you'll learn about our suggestions for how to go about studying, just like what are some of the best practices for studying. So if you have not done so, by all means, please, please, please come attend to session 1 and attend as many as you would like, right? If you do feel like taking a class with us, find a teacher, an instructor that you like, yeah? Come hang out with one of us that you resonate with. Tonight was a pleasure. I am so glad I got to hang out and work with y'all this evening. This very end of February 2022, I cannot believe. Definitely come check out our courses, check out more of our free prep hours. We have tons and tons and tons of them on the site. You can find the recording for this eventually. It's not there right now, but you'll be able to find all of the recordings. And again, this one, once it's uploaded, on our YouTube channel, where you can get all of our free prep hours there. Yeah, for sure. For sure. And if you'd like to check out our YouTube channel, you can do so. Let me get you a link. And let me try and get one that doesn't just start playing. But you can come and see, we've got, I don't know, like maybe 90 or more hours of things on our free prep hour site. And so let me get you our link. If you're looking for any of our GRE stuff, here you go. There's playlists aplenty at that link. Right, we've got 3 vocab playlists. We've got this free prep hour playlist. We've got some like fun question playlists where we went through and did a whole bunch of questions for you to practice, and then we give you our expert explanations. So come and hang out with us more. Come hang out at more free prep hours. Right, we got 2 every month. Have a lovely rest of your evening or early morning for some of you, and hopefully we'll see you around soon. Bye, y'all.